inverse trigonometric inverse trigonometric functions. We need to learn the inverse trigonometric functions. As we learned before, any function to have an inverse, it should be one-to-one function. Should be one-to-one function. Let's start with the first trigonometric function, sine function. Y is equal to sine x. Okay, this function, this is the graph of y equal to sine x. This is the plot or the graph of the function y equal to sine x. If this function is one-to-one function, this function seems from the graph here, it is not one-to-one function. If you draw a horizontal line, it will cut the plot more than one. It will cut the plots more than one. Actually, because all trigonometric functions are periodic functions, so they are not one-to-one. They are not one-to-one in their domain. If you draw a horizontal line, it will cut the plot more than one. So to find the inverse, we need a one-to-one function. To find the inverse, we need one-to-one function. So the question is how I can find one-to-one function from sine x. To find one-to-one function, we need to restrict the domain. The function is not one-to-one in its domain. So you need to restrict your domain to find a function one-to-one. So if we take only this part, look for this part. This part is one-to-one. This part, only the red one, this one. This part is one-to-one, one-to-one function. If you draw a horizontal line, it will cut the red line only once. The red line only once. So this red line starting from pi over 2 minus pi over 2 until pi over 2. Until pi over 2. So this will be your domain. We will restrict the domain. The domain of sine x is all real number, but at this domain, the function is not one-to-one. At this domain, the function is not one-to-one. So I need one-to-one function. So I will restrict the domain from minus pi over 2 to pi over 2. From minus pi over 2 until pi over 2. Here, this part only. At this domain, from minus pi over 2 to pi over 2, sine x is one-to-one. Sine x here is one-to-one. If you try to draw any horizontal line, it will cut the graph only once. So at this domain only, we can find the inverse. At this domain only, we can find the inverse. So here, this is the function. The function is not one-to-one, but if the domain is restricted from minus pi over 2 to pi over 2, the function will become one-to-one function. Okay, how I can find the inverse? First, your domain from pi minus pi over 2 to pi over 2, this domain will become your range. If you look here for this, the range here from minus pi over 2 to pi over 2, this is your range. The range here will be your domain from minus 1 to 1. This is the range for sine x. This will become your domain for sine inverse. This is domain from minus 1 to 1. So we will replace y, the range, to x-axis, and the x-axis here, the domain here, to be range here. So the domain for sine x from minus pi over 2 to pi over 2 will become the range for sine inverse. And the range for sine from minus 1 to 1 will become your domain. Then we will reflect this one around the line y equal to x. We will around this graph, around the line y equal to x. This is the graph that we plot. This is the plot of sine inverse x. Sometimes we call it arc sine x. Arc sine x. Okay, now the function y sine inverse x, x will be equal to sine y. So this function have a range from minus pi over 2 to pi over 2, have domain from minus 1 to 1. This domain was the range of sine x. The domain of sine x becomes the range of sine inverse x. Same for cosine function or cos x. This function, if you look for cos x, also the function is not 1 to 1. This function in its domain is not 1 to 1. If you draw a horizontal line, it will cut the graph more than 1. So to make it 1 to 1, you have to restrict the domain. You have to restrict the domain. So I will choose this part. I will choose only this part. Let's this one. From this part, from 0 to pi, here, this part is 1 to 1. If you look for this part only, this part is 1 to 1. If you try to draw any horizontal line, it will cut the red part only once. It will cut the red part only once. So I will define the inverse only on the domain from 0 to pi, because the function at this domain is 1 to 1. So if you need to define the inverse, your domain here from 0 to pi will become your range. Your domain will become your range from 0 until pi. And your range here from minus 1 to 1 will become your domain. From minus 1 to 1 will become your domain. And this plot or this graph will be reflected around y, the line y equal to x. Or you can make a table. If you don't like to reflect, you can make a table. But if you make a table, take the x values between minus 1 and 1, because your domain only from minus 1 and 1. Then find the cos inverse and plot. You will plot this graph. You will plot from 0 to pi. From 0 to pi. So this is the plot of cos inverse x. The domain here from 0 to pi become your range. Your range become your domain. Your range become your domain. Your domain from minus 1 to 1 for cos inverse, and the range from 0 to pi, because at this domain, the original function is 1 to 1. Similar for tan x, this function. I need to find the inverse for this function. This function originally is not 1 to 1. This function originally is not 1 to 1, so I will choose only this part. This part, the function is 1 to 1. So from minus pi over 2 to pi over 2. At this part, the function is 1 to 1. But on its domain, not 1 to 1. If I draw a horizontal line, it will cut the graph more than 1. But from minus pi over 2 to pi over 2, the red one, the function is 1 to 1. If you draw any horizontal line, it will cut the red line only once. Now this function, the domain from minus pi over 2 to pi over 2 will become the range of tan inverse. Will become the range. And the range here the range is all real number. So the domain for tan inverse will be all the real numbers. All the real numbers. Here we have a horizontal dot line at the points minus pi over 2 and pi over 2. Here you will get a here we have a vertical dot line. Here we have a horizontal dot line. The dot line means that the function is undefined at this point. You cannot find tan inverse equal to pi over 2 or minus pi over 2, because tan at minus pi over 2 and pi over 2 is undefined. The dot line means that the function at this point is undefined. So here the inverse function is defined. Y is equal tan inverse x, x is equal tan y. the domain become all the real number because the range for original one is all real numbers. And the range from minus pi over 2 at pi over 2 because the original function is 1-to-1 at this domain. Any question? I need to show you. Yes, stop sharing this. I will share with you. Okay, I will share with you this. If you look here, okay, if I draw the function sine x, this is the function sine x. Okay. If I draw the inverse for the function on its domain, I will reflect this graph around the line y equal to x. This is the line y equal to x. So show the inverse. The inverse will become like that. If I reflect the sine function in all its domain. This kind of plot is not a plot for a function. Is not a plot of a function, not a graph of the function. So this is why we cannot define the inverse on all the function domains, in all the function domain. So I have to restrict the function of sine x domain. So here, if I restrict from minus pi over 2 to pi over 2, I will choose this part is 1-to-1. So now you can reflect this part around line y equal to x. So this is your inverse for sine inverse x. Similar if you go for cosine x. Similar if you go for cosine x. This is the cosine function on its domain. If you reflect this one, you get this plot, not a plot for the function. It's just normal relation, not function. So you have to choose a part that is 1-to-1 here from the original function. So I will restrict the domain. I will restrict the domain from 0 to pi. From 0 until pi. This one. This part now is 1-to-1. This part is 1-to-1. This is the line y equal to x. So just reflect this one to show the inverse relation. So this is the plot of cos inverse x. This one. Similar for tan. If you draw the tangent of its domain, this is the function of tan x on its domain. If you try to reflect the function on its domain, you get this kind of a plot. This kind of a plot is not a plot of a function, because if you draw any vertical line, it will cut the graph more than once, which means it is not a function. Which means it's not a function. So you have to choose 1-to-1 part. 1-to-1 part. So here I will restrict the domain from minus pi over 2 until pi over 2. This part. Only this part. Now you can reflect around the line y equal to x. So this has become your relation. When we make a reflection or symmetrical around y equal to x, this is the graph of tan inverse x. Okay. This is why we have to restrict the domain. We have to restrict the domain. Again, go back now to our original file. Inverse cotan function. Similar as we did for tan and sine and cosine, we define the cotan function. Okay, this is the original plot for cotan x. This is the original plot for cotan x. Y equal cot x. This function is not 1-to-1. This function is not 1-to-1. So to define the inverse, I have to make it 1-to-1 function. So I will choose only this part. This part is 1 to 1. Now the domain here from 0 to pi. From 0 to pi. So will become our range here. When I define, this is the graph of cot inverse x. This one is cotan inverse x, or arc cotan x. Same. Now the domain here from 0 to pi will become the range. The range here, which is all real numbers, this is the range, will become your domain. So your domain will be all real numbers. Similar for cosec x. Cosec x here, okay, make it bigger. Okay, cosec x here, this function is not 1 to 1. The original function is not 1 to 1. If you draw a horizontal line, it will not 1 to 1. So to make it 1 to 1, you have to choose a part that is 1 to 1. So I will choose this one. This one and this one. If you look at these two parts, the function is 1 to 1. The function here for the red one. So the function is 1 to 1. So the domain from minus pi over 2 to pi over 2, from minus pi over 2 to pi over 2 will become your range. From minus pi over 2 until pi over 2. But we will exclude the 0 because the original function here is undefined at 0. At 0 we have a vertical dot line. At 0 we have vertical dot line, so the domain is from minus pi over 2 to pi over 2. We have to exclude 0. We have to exclude 0. Right here. From minus pi over 2 to pi over 2, exclude 0. Okay, what about the domain? I need to know the domain of inverse cosec function. So I have to look at the range for the original one. What is the range here? What is the range here? What is the range for cosec x? I need to know the range, then you can know the domain. Can you know the range? Can you know the range for this function? So this range will become your domain here. What do you think is the range?
Y greater than 1, y smaller than
Yes.
negative 1.
Yes, from minus infinity to negative 1. And from 1 to infinity. From 1 to infinity here, and from minus infinity to minus 1. From minus infinity to minus 1, and from 1 to infinity. Because we have no graph between minus 1 and 1. So this is the range here will become your domain at this area. Similar for secant x. Secant x is not one-to-one function. Sec x is not one-to-one function. So to make it one-to-one, okay, this is sec x. To make it one-to-one, you have to choose this this part. This one and this one. These two parts, the function is one-to-one from 0 to pi. from 0 to pi. So this domain will become your range. So your range from 0 to pi except pi over 2. We will exclude pi over 2. And the domain here, which is all real, the range here, which is 1 to infinity, and from minus infinity to minus 1 will become your domain. So if I need to define the domain and range here, if you need to define, so the domain will be, the domain you have to look for the range here. The range is from minus infinity to minus 1 and from 1 to infinity. From minus infinity to minus 1 plus 1 to infinity. Okay, if you need to know the range, you have to look for domain there. Range for inverse. This is the y I think sec inverse x. Here, you know the range. You have, this is the function sec x. You need to know the domain here to go for the range. The domain is from 0 to pi, except the point pi over 2, because we have a vertical dot line here. So it will be from 0 to pi. And exclude pi over 2. Pi over 2. So generally, these are the function sine inverse, cos inverse, tan inverse, cosec inverse, sec inverse, cot inverse. These are the domain and range. The domain here, same with the range for your original function. The range for your original function become your domain here. The range of sine from minus 1 and 1, so this is the domain for sine inverse. The range of cos from minus 1 and 1, this is become the domain for your cos inverse. The range for tan was all real number, so this has become the domain for your tan inverse. And the range here is the restricted domain for the original function. The restricted domain that make the original function 1 to 1 will become your range. So generally, sine inverse x not equal to 1 over sine x. Generally, sine inverse x not equal to 1, because 1 over sine x, this function is cosec x. 1 over sine x, this function is cosec x, so not equal to sine inverse x. But if I say sine x to the power minus 1 like this, yes, we can say that is 1 over sine x. So these expressions are different. So you need to be careful. Right. These expressions are different. Inverse trigonometric functions. These are formulas. Usually, the function when it's with its inverse can cancel each other, can delete each other. When I say sine inverse x, it is always equal to x. Sine inverse sine y, it is equal to y. Cos inverse x equal to x. You can cancel or eliminate cos with its inverse. Cos inverse cos y goes to y. Tan inverse x equal to x. Tan inverse tan y is equal to y. So these are formula usually when any function with its inverse should be eliminate each other. But my question is this formula here for the trigonometric function always true or not? Do you think it is always true that sine inverse x equal x, sine inverse sine y equal y, this one? Are these function always true? You can open the mic or can answer on the chat. No. One of your friends say no. What about the other? Do you think it is yes or no? Do you think these formulas always true? Sine inverse x equal x, sine inverse sine y equal y, cos inverse x equal x, cos inverse cos y equal y. Okay, we have two now, say no. Okay, these relations are not always true. Not always true. Why? Because you need to be sure that your result here or the x here within the range for this function. So the range of sine x from -1 to 1, so you need to be sure that x within the range of sine here. X should be from -1 to 1. Similar here, sine inverse sine y equal to y, you need to be sure that y is within the range of sine inverse. The range of sine inverse from minus pi over 2 to pi over 2. So you need to be sure that your value within this range. Similar here, x should be within the range of cos. To say that cos inverse x equal to x, which means x should be a value from -1 and 1. Similar here, y, you need to be sure that y within the range of cos inverse. Y is within the range of cos inverse. So y from 0 to 180. Any other value not within this range, this relation is not true. X should be within the range of tan x, but since the range of tan is all real number, so you have no problem for this one. But here when I start with tan inverse tan y not always equal to y. Y should be within the range of tan inverse. To say that tan inverse tan y equal to y, you need to be sure that the y value is within -90° to 90°. This range for the function tan inverse, the first function here. So this is not always true. You need to be careful for your range here. Here we have these some identities. These identities will be given to you in the exam, but here we will prove. We will show that sine inverse x plus cos inverse x is equal to pi over 2. Tan inverse x plus cot inverse x is equal to pi over 2. Sec inverse x plus cosec inverse x is equal to pi over 2. Here, cosec inverse x is equal to sine inverse x for 1 over x. Sec inverse x is equal to cos inverse 1 over x. Cot inverse x is equal to tan inverse 1 over x. 1 over x. Here this is true when the absolute value of x greater than 1, to be sure that this value less than 1. And this one is true only for positive x. These relations are true only for positive x. Also, we have sine inverse. This one also we will prove. Here, sine inverse minus x is equal to minus sine inverse x. This means this function is an odd function. Since the function at negative value is equal to the positive multiplied by plus here, or we can take the plus outside, the minus, sorry, outside. This means this function is an odd function. Sine inverse for the negative value is equal to sine inverse for the positive value multiplied by minus. Or we can take the minus outside. So this function, this property means that this function is an odd function. Sec inverse minus x is equal to pi minus sec inverse x. Cos inverse minus x is equal to pi minus cos inverse x. Cos inverse x. Any question before going to example? Any question? If everything is okay, write in chat that you are okay. Then we continue. Okay, that's good. What about the others? Where are the other students? Okay, never mind. Now sine inverse 0.5. Okay, that's it. Sine inverse 0.5. This one equal to what? Sine inverse 0.5 equal to what? 0.5. Yes, correct. 0.5. Sine inverse 0.5. The sine with sine inverse will eliminate each other. So sine inverse 0.5 is equal to 0.5. Okay, the second one. Sine inverse 3. Sine inverse 3. This one. Sine inverse 3 equal to what? Sine inverse 3. Sine. Sorry. Sine inverse 3 equal to what? 3, 3, 3. Where are the other students? Sine inverse 3 equal to what? 3, 3, 3, 3, 3, 3, 3, 3. Oh, we have students say math error. Good, Fatin. Good. Math error. Good. We have math error here. Math error. Yes. It is a math error. For sure it should be a math error. 3 is greater than 1. 3 is not within the range of sine. I told you this relation, you need to be sure the result is within the range here. 3 is not within the range of sine. Sine always between -1 and 1. So this is undefined. You cannot say it is equal to 3. You cannot say it is equal to 3. So here sine, this one is undefined. You cannot. Math error. Why? Because 3 is not within the range of sine. Sine cannot be equal to 3. Cannot be equal to 3. Sine always between -1 and 1. How I can say that sine for any value is equal to 3? So this is a math error. So be careful before answering. Not always, I told you this relation is not always true. Here, when I explain this, I told you this is not always true. You need to be careful for the range here. Because in the exam, we didn't ask you what is the range of sine or what is the domain of sine inverse. We just give you like these examples. You need to be careful for the domain and the range for the function. Okay, sine inverse sine 45. Sine inverse sine 45. Sine inverse sine 45. Sine inverse sine 45. Is it equal to 45? 45. Okay, good. Okay, 45. Okay, the last example, the last one, sine inverse sine 135. Sine inverse sine 135. Sine inverse sine 135. This one equal to what? Undefined. Okay, undefined. So are you sure? Oh, we have undefined, all undefined. So all of you agree it is, oh, we have 45 degree here. Good, we have an answer here. Okay, this one, not undefined, it is one defined, but not equal to 135. Okay, this one will not be equal to 135. Okay, but we can get a result. We still can get a result. I will search for a function, because sine inverse from minus pi over 2 to pi over 2, right? Sine inverse, this relation from minus pi over 2 to pi over 2. So you need to find an angle within this range. You need to find the angle within this range. So this is, I agree with you, not equal to 135, because this is out of the range. So you need to find another one within the range. So sine inverse, so this one will become, will equal to sine inverse. The sine of 135, the sine of 135 is equal to minus, I think minus 1 square root of 2 over 2, I think. Sine inverse for this value. Sine inverse for this value. Sine 135 is sine inverse. Try to find sine 135. Sine 135 is equal to this value. Now you need to find sine inverse for this negative value. But you need to find an angle between minus pi over 2 to pi over 2. Okay, from minus pi over 2 to pi over 2, which is the first quadrant and last quadrant. So the sign is negative in the fourth quadrant or the last quadrant. So you need to take your angle from the last quadrant, which is minus 45 degree. Minus 45 degree. You need angle, not 45. It is minus 45 degree because we find, oh, sorry, this one sine 155 is a positive, not negative. Yes, yes, correct. So it would be 45. Sorry. Should be 45 degree. Yes. Sine inverse, because sine 135 is positive. Yes, so sine inverse for a positive value, you need to choose an angle from minus pi over 2 to pi over 2, which is 45 degree. 45. So sine inverse sine 135 not equal to 135. You cannot cancel or eliminate these together to say it is equal to 135, because 135 is not within the range for sine inverse. So how I can answer this one? You need to try to find sine 135. This value is positive. So sine inverse for this positive value should be an angle from the first quadrant. So it is 45 degree. If you try to calculate sine inverse for this positive value, it will give to you 45 degree. 45 degree. Generally, okay, we can, I explain to you like this. Sine inverse is the range of sine inverse is from minus pi over 2 to pi over 2. Here. This is a sine inverse. So if you calculate a sine inverse for a positive value, take your angle from the first quadrant. If you calculate sine inverse for a negative value, take your angle from last quadrant, because sine inverse is between minus pi over 2 to pi over 2. Similar for tan inverse. Tan inverse also. If tan inverse for a positive value, take your angle from the first quadrant. Tan inverse for a negative value, take your angle from the last quadrant. Cos inverse is defined from 0 to pi. So cos inverse from first quadrant, and the cos inverse for the negative value from second quadrant. Because the range of cos inverse is from 0 to pi. Cos inverse is from 0 to pi. So if you calculate cos inverse for a negative value, you choose your angle from the second quadrant. If you cos inverse for a positive value, take your angle from the first quadrant. Sine inverse, tan inverse, positive value, first quadrant, negative value, fourth quadrant, last one. So here, sine inverse, this sine 135 is positive. So I need sine inverse to the positive value. So I have to choose an angle from the first quadrant, which is 45 degree. But for example, if I calculate sine inverse For example, if I calculate sine inverse, for example, for sine 225, sine inverse, so this one will be equal to sine inverse. Okay, sine 225 is minus square root of 2 over 2. This one is negative. So sine inverse for a negative value should be a value from the fourth quadrant from here, which is minus 45 degree. Minus 45 degree. Minus 45 degree. So you need to be careful for this range. So here we cannot say it is undefined. We can find a result. We can find a result, but we can say it is not equal to 135. It is not equal to 135. You can still find a value. Any question? If you have any question, you can open the mic or you can write your question on the chat. You can. If you also like to repeat anything, I can repeat. If anything is not clear with you, just you need to be careful for your function here. The first one, be sure that the result is within the range. Is not within the range, like here sine inverse 3, so it is undefined, or sometimes we can find another angle or another answer. Okay, if there is no question, we go for another example. I need to find the values of arcsec or sec inverse sim. Arcsec or sec inverse sim. Sec inverse minus 2. Sec inverse minus 2. Sec inverse minus 2. Sec similar to cos. Sec similar to cos. Because sec is equal to 1 over cos x. So sec for a negative value should be a value from the second quadrant here. Sec for a negative value should be a value from the second quadrant. So here your answer is 100. You need to find a sec for minus 2, which is sec for 2 is 60. For in second quadrant, 180 minus 60, which is 120 degree. Sec inverse minus 2 is 120 degree. You have to choose the value from the second quadrant. Why? Because sec similar to cos from 0 to pi. From 0 to pi. Since it is from 0 to pi, you have to choose your negative value from the second quadrant. From the second quadrant. Okay. Cosec inverse root of 2. Can you calculate this for me? Cosec inverse the root of 2. Equal to what? Cosec inverse the root of 2. Cosec inverse the root of 2. Try to calculate this one. What is equal to what? Cosec inverse the root of 2. 45 degree. We have two students already calculated. 45 degree. Yes, because cosec similar to sine. Cosec similar to sine. Cosec for a positive value should be an angle from the first quadrant. Should be an angle from the first quadrant. So this one will be equal to 45 degree. Will be equal to 1 because cosec this one is this is the also positive on the second quadrant, but cosine follows sine. Sine for positive value should be from the first quadrant, for negative value should be from the fourth quadrant. So cosec will be, for a positive value, should be an angle from the first quadrant. So it will be 45 degrees. Okay, the last one. The last one. Cot inverse minus 1 over square root of 3. Cot inverse. How you get our cos minus 2 100. This one sec inverse. This one sec inverse, not cos inverse first. This one sec inverse, not cos inverse. Okay. So because cos inverse for minus 2 cannot, because cosine is from minus 1 and 1. So this is sec inverse, not cos inverse. Okay, so here is a negative value. Okay, sec is negative. Sec is negative on the second quadrant and on the third quadrant. But the sec inverse range is from 0 to pi. So you have, if you calculate sec inverse from positive value, take your angle from the first quadrant. If you calculate sec inverse for a negative value, you have to take it from the second quadrant. Because here I draw for you this picture just to make it easy for you. Now cos inverse is positive at the first quadrant, negative at the second quadrant. Cos inverse, we defined it, we restrict the domain for cos from 0 to pi. So this one, you have any value should be within this. This is should be from 0 to pi, within this range, from 0 to pi. So when I calculate sec inverse to minus 2, sec similar to cos, because sec is equal to 1 over cos. Sec is equal to cos. So because sec inverse, okay, you can maybe, to make it more clear. This one is equal to cos inverse minus 1 over 2. It is equal to cos inverse minus 1 over 2 using this relation. Sec inverse is equal to cos inverse 1 over x. Okay, so I calculate cos inverse for a negative value. Cannot be an angle from the first quadrant, should be from the second quadrant. Because your range for cos inverse from 0 to pi. So from second quadrant, because cos 60 is 1 over 2. So I will not take 60 degree. I will take the equivalent value in the second quadrant. So it will be equal to 180. It will be equal to 180 minus 60 degree, which is 120 degree. Okay. Now, cot inverse minus 1 over square root over root of 3. Cot inverse minus 1 over root of 3. It is equal to what? Cot inverse minus 1 over root of 3. Okay, cot inverse, similar to cos. It should be from 0 to pi. Should be here from 0 to pi. Cot inverse for the negative value should be here, like to cos, because it is defined from 0 to pi. It is defined from 0 to pi. So cot inverse to minus 1 over root of 3 should be an angle in the second quadrant. should be an angle in the second quadrant. Now the 60 degree have cot equal to 1 over root of 3. But because I have a negative value, you need to choose the value in the second quadrant, which is 180 minus 60, which is 120 degree. 120 degree. So you need to, before answering this one, you need to know the range. You need to know the range. You need to be careful within this range here. This range. We need to be sure that all the ranges is okay. The range of cot, the range of sine inverse, the cot inverse from 0 to pi. So your angle similar to cos from 0 to pi. So your angle either from the first quadrant or second quadrant. So here it is 1. So cot for negative value should be a value from second quadrant. So 180 minus 60, which is 120 degree. 120 degree. Any question? Any questions? Where are the other students? If everything is okay, write okay on the chat. If you have any question, open your mic and ask, or you also can write your question on the chat. This chapter is very important. This chapter is included in your exam. I know that most of you starting their holiday already, but you have to study this chapter well. Okay, any question? Okay, no question. Good. Now we need to prove sine inverse x plus cos inverse x is equal to pi over 2. Sine inverse x plus cos, I need to prove this one. This is identity will be given to you in the exam, but we will ask you, maybe we ask you to prove how we can prove that sine inverse x plus cos inverse x is equal to pi over 2. Is equal to pi over. Maybe I will, okay, I will prove number 2 first. This one. Okay, I will go back again for this. Okay. Cos sine, and I will prove number 2 first. Cos sine inverse x is equal to root 1 minus x squared. To prove this one, cos sine inverse x is equal to root 1 minus x squared, I will take sine inverse x here, this one. I will assume it equal to theta. Let theta is equal to sine inverse x. Let theta is equal to sine, and I will replace this value, sine inverse x here. I will replace this value, sine inverse x. I will replace it by theta. So what I need to prove that cos theta is equal to root 1 minus x squared. If I assume this is equal to theta, you need to prove that cos theta is the root 1 minus x squared. Okay, how I can find cos theta? I have theta is equal to sine inverse x. This means what? What you can understand from that theta is equal to sine inverse x. Theta is equal to sine inverse x. How we can prove that theta is equal to sine inverse x? What you can understand from this one? What we means by theta is equal to sine inverse x? This means that sine theta is equal to x. When I say that theta is equal to sine inverse x, this means that sine theta equal x. Sine theta equal x. Okay, I need cos theta, not sine theta. I need cos theta because we need to prove that cos sine inverse x is the root of 1 minus x squared. We need to prove cos theta is equal to the root 1 minus x squared. I have sine theta, not cos theta. From sine theta, how I can find cos theta? How you can find cos theta? So here you have two options. You can use the identity that sine square plus cos square is equal to 1. Can. Or you can draw a triangle. Also can. If you have theta, you can use the identity that sine square plus cos square is equal to 1 to find cos theta. Or you can find a triangle with right angle. Sine theta is the opposite over hypotenuse. So x over 1. X over 1. So to find the adjacent, it will become 1 minus x squared. Why? Because always hypotenuse square is equal to adjacent square plus opposite square. Opposite square. So 1 is equal to x square, equal to adjacent square plus x square. So the adjacent will be the root of 1 minus x squared. Or you can use the identity that sine square plus cos square is equal to 1. Also can. So from here, you can find that, or you can prove that cos theta is the adjacent over hypotenuse. So root of 1 minus x squared over 1. Cos theta is root of 1 minus x squared. So here theta is sine inverse x is equal to root 1 minus x squared. So this is how we find the second relation. This is how we can find the second relation, this one. We already proved this one. Any question? Okay, now we need to prove the first one. I need to prove the first one. Sine inverse x plus cos inverse x is equal to pi over 2. Sine inverse x plus cos inverse x is equal to pi over 2. Sorry, number the first one. Now I will go back for the first one to prove. Sine inverse x plus cos inverse x is equal to pi over 2. Similar what I did here, I will assume theta is equal to sine inverse x. I will assume theta is equal to sine inverse x. Let theta equal to sine inverse x. So this means that sine theta equal to x. Sine theta equal to x. Now I need to use this information. Sine theta is equal to x. Sine theta is equal to x. I will draw the triangle again. This theta. Sine theta is opposite over hypotenuse. X over 1. X over 1. I need to prove that sine inverse x plus cos inverse x is equal to pi over 2. This is what I need. So I have sine inverse x. I assume that sine inverse x equal to theta. So we have sine theta equal to x. Now look for this value, for this angle. This angle equal to what? In terms of theta, equal to what? 90 minus theta. Yes, this one is 90 or pi over 2 minus theta. Pi over 2 minus theta. because the triangle is the summation of the angles of the triangle is 180. I have a right angle here, pi over 2, so the other two angles should be equal to pi over 2. So pi over 2. So this, if this angle is theta, this angle pi over 2 minus theta. If this 30 degree, this 60 degree. If this 20 degree, this should be 70 degree. Okay, can you calculate this angle? The cos of this angle? I need to find the cos pi over 2 minus theta. Can you find? X, yes, X. It should be the adjacent over hypotenuse. It should be equal to X. Should be equal to X. So cos pi over 2 minus theta is equal to X. This means that X, or cos inverse X, is equal to pi over 2 minus theta. This means if you take cos inverse for both sides, cos inverse cos pi over 2 minus theta will be equal to cos inverse X. So cos inverse X will be pi over 2 minus theta. If the cos of pi over 2 minus theta equal to X, this means that cos inverse X should go back again to pi over 2 minus theta. So now we have cos inverse X is pi over 2 minus theta. Sine inverse X is equal to theta. Sine inverse X is equal to theta. So I will calculate sine inverse X plus cos inverse X. Sine inverse X plus cos inverse X. Sine inverse X plus cos inverse X is equal. Sine inverse X is equal to theta. Cos inverse X is equal to pi over 2 minus theta. So theta with minus theta, so you have pi over 2 only. So this is equal to pi over 2. This one will be equal to pi over 2. Theta is cosine inverse X plus cos inverse X is pi over 2. So we already proved the first one. Now the last one, sine inverse minus X is equal to minus sine inverse X. Sine inverse minus X, we need it to show that it is equal to sine inverse X. We need to prove this one. So first I will assume that theta is equal to minus sine inverse X. I will assume theta is equal to minus sine inverse X. I will take this side. I will assume this side is equal to theta. So theta is minus sine inverse X. Here, rearrange this one. This means that minus theta is equal to sine inverse X. Minus theta is equal to sine inverse X. Sine inverse. What we can understand that minus theta is equal to sine inverse X. This means that sine minus theta is equal to X. Sine minus theta is equal to X. Take sine for both sides. Take sine for both sides. So you have sine minus theta is equal to X. So now sine minus theta equal to what? Sine minus theta equal to what? Sine minus theta equal to what? when I say that sine minus theta equal to x. Sine minus theta equal to what? Not equal to minus x, no. Minus sine theta, yes, good. Minus sine theta. Minus sine theta. Because sine is an odd function. Sine is an odd function. Minus sine theta is equal to x, or we can say that minus x or sine theta is equal to minus x. Here sine minus theta, because sine minus theta is an odd function, it is equal to minus sine theta. We can replace this one by minus sine theta is equal to x. Now rearrange again this part. So sine theta is equal to minus x. To minus x. Now take sine inverse for both sides. Take sine inverse for both sides. So you will get that theta is equal to sine inverse minus x. Sine inverse minus x. So theta is equal to minus sine inverse x, and also equal to, from here, theta is equal, from the beginning we assume that theta is minus sine inverse x, and we prove that theta also equal to sine inverse minus x. So which means that these two are equal. These two are equal. So this means that this is equal to minus sine inverse x. This is equal to minus sine inverse x. So first, I assume that theta is equal to minus sine inverse x, which means that minus theta is equal to sine inverse x. What we can understand, that means that x itself, you take the sine of both sides, x is equal to sine minus theta. Sine minus theta, it is an odd function, so it is equal to minus sine theta, which is equal to x. I need to find sine inverse to minus x. So sine theta is equal to minus x means that theta is equal to sine inverse minus x. And also theta is minus sine inverse of x, so these two are equal. If you have a look for the three proof, we depends on the identities. We depends on the identities to prove. Here you can use sine square plus cos square is equal to 1. And also you can use the definition of cos and definition of sine. Here we assume that sine theta is equal to cos pi over 2 minus theta. This is one of the identity also. Sine theta is equal to cos pi over 2 minus theta. Here we prove the odd identity, which means that sine minus theta is equal to minus sine theta. So in your proof, you will use the trigonometric identity. You will depend on trigonometric identity to show these relations are correct. Now I will give you another example. If you have any question, just write directly on the chat. I'm looking for the chat, what you are writing. So if you have any question, just write on the chat. Now here I'm 2 sine inverse x. This example, we will not prove. We will find the value of x. We will solve the relation. We will solve the equation. Because we have two type of questions we usually ask you. Some question ask you prove this relation, show that this relation equal to this, like this one, like example number 3. Show that this part is always equal to pi over 2. This part is equal to, this is the relation, or this identity is true for all values of x. Is true for all values of x. Here, this relation 2 sine inverse x plus sine inverse to x equal to pi over 2 is true only for some values of x. We need to find these values. We need to find these values. 2 sine inverse x plus sine inverse 2x equal to pi over 2. We need to find the value of x. So first, I will assume that let a is equal to sine inverse x, p is equal to sine inverse 2x. So this relation, just to simplify the relation, 2a plus, I will replace sine inverse x by a, any variable, sine inverse 2x by b. So 2a plus b is equal to pi over 2. To pi over 2. This is your equation. This is that equation we need to solve. This is the equation we need to solve. But I just replace sine inverse x by a variable a, sine inverse 2x by a variable b. So your equation that you need to solve is 2a plus b is equal to pi over 2. We need to find the values of x that make this relation is correct. What we can understand from a is equal to sine inverse x. This means what? A is equal to sine inverse x. A is equal to sine inverse x. Sine A equal to x. Sine A equal to x. Yeah. Okay, what we can understand from B is equal to sine inverse 2x. B is equal to sine inverse 2x. What we can understand from this one? Sine B is equal to x. Yes. Sine B is equal to x. Okay. So next, what we can understand from sine A is equal to x and sine B equal to x. Sine A is equal to x, sine B is equal to x. Okay, what next? What we can conclude from this one? Sine A is equal to x. Sine B is equal to x. What you can conclude? Yes, sine B is equal to sine A. Sine B is equal to sine A. Sine B is equal to sine A. So I have this relation, sine B is equal to sine A. Now if I multiply both relation or both side by cos A, so you will get that sine B cos A is equal to sine A cos A. I will multiply both side by cos A. So sine B cos A is equal to sine A cos A. 2 sine A cos A. Okay, the question is this side, 2 sine A cos A equal to what? This side. The side 2 sine A cos A equal to what? Sine 2A, yes. So I have sine B cos A is equal to sine 2A. Now if I can find the values of sine B cos A, sine 2A based on x, I will get equation that have x variable and I can solve it to find the value of x. Sine B, from here it is equal to x. Sine B already we have equal to x. So this one we can replace it by 2x. Okay, what about cos A? I have sine A equal to x. I need to find cos A. How I can find cos A? I have sine A, not cos A. Sine B is okay already here, 2x. Now cos A, I have sine A equal to x. I need to find cos A. How I can find it? 1 minus sine square A. The root of 1 minus sine square A. The root of if you need to use the identity that sine square A plus cos square A equal to 1, if you use this identity, it will be the root of 1 minus sine square A. Okay, so here you have two options. You can use the identity that sine square A plus cos square A is equal to 1. So cos square A will be the root of 1 minus sine square A, which is root 1 minus x squared. You can use this, but not equal to 1 minus sine A. It is equal to the root 1 minus sine square A. Can. Or you can draw a triangle. This is A. Sine A is x. So the cos A will be the root of 1 minus x squared. Because this one will be 1 square minus x squared give you the adjacent square. So take the root, so 1 minus x squared. So this is cos A. This is cos A. This is cos A. Cos A is equal to the root 1 minus x squared. So now I have sine B in terms of x, which is 2x. Sine cos A, we already find is equal to the root 1 minus x squared. So we can write sine B in terms of x, cos A in terms of x. What about sine 2A? How I can find the value sine of 2A? Here we have sine A and sine B, but I need to calculate sine 2A. Because if I can write sine 2A in terms of x, so this equation, sine B in terms of x already, cos A we already written in terms of x. So I need to write it sine 2A in terms of x, so I have equation only include x. I can solve this equation and find the value of x. Look here, you have 2A plus B is equal to pi over 2. This one. 2A plus B is equal to pi over 2. Okay, from here, you have two options to calculate. Yes. First option, you can say that from here. 2A is equal to pi over 2 minus B. Right? 2A is equal to pi over 2 minus B. So sine 2A will be equal to sine pi over 2 minus B. Sine pi over 2 minus B. And you can use the identity to calculate this one. Or another option, you can draw the triangle again, but for B. Because if this angle is B, this angle should be 2A. Because B and 2A equal to pi over 2. B and 2A is equal to pi over 2. So both angles is equal to pi over 2. If this angle is B, this angle should be 2A. Now the sine of B is equal to x. The sine of B is equal to x. Okay. So the sine of 2A, you need to find this angle, this adjacent here, which is 1 minus 4x squared. 1 minus 4x squared. So you can calculate by using this identity to find, or you can use the triangle here, B, this angle should be 2A. Now sine B, 2x over 1. So this adjacent is 2x. The hypotenuse here equal 1. So the opposite here to x, the hypotenuse 1, so the adjacent, the root of 1 minus 4x squared. Now, sine 2a from here will be equal to the root 1 minus 4x squared. If you don't like to draw the triangle, because I feel it is easier, but if you more comfortable to use the identities, it's still okay. You can use the identities, because this one will be equal to sine y over 2 cos b plus, sorry, minus, because it is sine, minus cos by over 2 sine b. But you still have to draw the triangle again to calculate cos b. So if you draw the triangle, so it is easier to go here directly. Because in both cases, if you use this identity, you still need to calculate cos b. Cos b, you have to use this triangle. But still okay, still acceptable answer. If you draw the triangle, this angle is b, this angle is 2a. Why? Because we have from the relation that 2a plus b is pi over 2, is equal to pi over 2. So if this angle b, this angle 2a. Okay, I need to find sine 2a, I have to find the opposite for 2a here, or the adjacent for b. Okay, sine 2b is equal to x. So this side is 2x, the hypotenuse here is 1. So to find the adjacent for b, or opposite for 2a, you need to, it is the root 1 minus 2x squared, which is 4x squared. This is sine 2a. Now you can substitute here. Sine 2b is equal to x. Sine 2b is equal to x. Cos a. Sine b is 2x. Cos a is the root of 1 minus x squared. Root of 1 minus x squared will be equal to sine 2a equal to 1 minus 4x squared. So here you have equation includes x only. Here you have equation that includes x variable only. You can solve this equation to find the value of x. So here I write the answer for you. To solve this equation, first you need to delete the root. So I will make the square for both sides. I will take the square of both sides. So 2x squared will become 4x squared. The root 1 minus x squared will become 1 minus x squared. The root of 1 minus 4x squared will become 1 minus 4x squared, squaring both sides. Squaring both sides. So 4x squared minus 4x to the power 4 is equal to 1 minus 4x squared. We just multiply here. 4x squared and this one. 4x squared times 1 is 4x squared. 4x squared times minus x squared is minus 4x squared. Is minus 4x squared. Now, 8. Here I just multiply. Now we have 4x squared minus 4x to the power 4, because 4x squared to x squared, x to the power 4 is equal to 1 minus 4x squared. Just rearrange this equation. Minus 4x squared plus, when you transfer here, it becomes plus. 4x squared plus 4x squared is 8x squared minus 4x squared equal to 1, or transfer 1 also, so minus 1 equal to 0. So this equation can be solved, or this we need to rearrange again, because for the highest power is x to the power 4. So 4x to the power 4, I will multiply by negative all the equation, minus 8x squared minus minus 1 will become plus 1 equal to 0. Just multiply the equation here by minus 1. Just multiply the equation here by minus 1. So you get 4x squared minus 8x squared plus 1 equal to 0. Equal to 0. Just multiply by minus. Now this quadratic equation, you can solve it for x squared. This quadratic equation, you can solve it for x squared. B here is equal to minus 8. A is equal to 4. Here you have A is equal to 4. A equal to 4. P is equal to minus 8. A is equal to 1. C, sorry. C is equal to 1. So minus B, so minus 8 is 8. Plus or minus the root. B squared, which is minus 8 squared, which is 64. Minus 4AC. 4 times 4 is 16. Over 2A, over 2 times 4, which is 8. So this is x squared. Take the root to find x. Take the root to find x. Take the root to find x. So these are the values of x. We have two values. First value when we have positive sign. Second value when we have negative sign. Okay, so this is the value for x squared. So this is your x. This is your first answer. This is your first answer. Any question how we solve this equation? Here just a calculation. Just normal calculation. If any of this calculation is not clear, I can repeat to you. Until now, everything is clear. Okay, if there is anything not clear, just write on the chat. And since you don't have any question, I will ask you now questions. Here we have get x equal to 1.366. Should we accept this answer or reject? And why? Should we accept that x 1.3 this answer, or we have to reject? What do you think? Did you accept? Accept because x squared is greater than 0. Okay. Did you agree with Ting? Accept because x greater than 0. The students, are you accept or not? Accept. No, because more than 1. Reject because x is... Okay, when x bigger than 1, why we have to reject? What's the problem that x is bigger than 1? Out of domain, yes. X here is greater than 1. Good. X here is greater than 1. And we have sine A equal to x. Sine A equal to x. And sine B also equal to x. So you cannot find any A values that sine A equal to value greater than 1. X here should be value between -1 and 1. -1 and 1. So you cannot have answer greater than 1 because of the domain. So we have to avoid this solution. Now the negative, so this is when we take positive sign, negative sign, this is your answer. So this answer x is less than 1, so this is only your solution. This is the only your solution for this equation. So this equation is true only when x is equal to this value. This is the only value x that satisfies that equation. So after long calculation, we can find only one value of x. Okay, so here to solve any question, you need to benefit from all information given to you, because we have a given information and we need to use this given information to find the answer. So what I did here, I assume that sine inverse x is equal to a and sine inverse 2x is equal to b. So 2a plus b is equal to pi over 2. From the relation sine inverse x is equal to a, sine inverse 2x, I replace it by b. So 2a plus b is equal to pi over 2. Okay, what we can understand that a is equal to sine inverse x. This means that sine a equal to x. B is equal to sine inverse to x. This means sine b is equal to x. So sine b is equal to sine a. Sine b to x, which means 2 sine a, because sine a is equal to x. Okay, I need to use 2a. I need this one because I need to benefit from this relation. So I will multiply both sides by cos a. So sine b cos a is equal to sine a cos a. Now this part, this side is sine 2a. Sine 2a. Now sine b is equal to x. Cos a, you can calculate it either by using identities or by using triangle. So you have the root 1 minus x squared. Sine 2a similar, you can use the identity, this one, or you can use the triangle. So sine 2a is the root 1 minus 4x squared. 1 minus 4x squared. So just substitute in the all sides. Sine 2b, replace sine 2b by 2x. Cos a by the root of 1 minus x squared. Sine 2a by the root of 1 minus 4x squared. So you have equation only depends on x. Make the square for both sides. So you have 4x squared, 1 minus x squared. The square here will cancel the root, so 1 minus 4x squared. Now multiply 4x squared times 1 is 4x squared. 4x squared times minus x squared. So minus 4x to the power 4. Minus 4x to the power 4 is equal to 1 minus 4x squared. Now transfer 1 minus 4x squared and 1 to the next side. So 4x squared and plus 4x squared, 8x squared, minus 4x to the power 4, minus 1 equal to 0. Here this is the highest power, better to be positive, so multiply all the equation by negative. So 4x squared minus 8x squared plus 1 equal to 0. This is a quadratic equation, can be solved for x squared. A equal to 4, P equal to minus 8, C is equal to 1. So this is x squared, then x is have two options. X here have two options. So you have x when greater than 1 should be rejected because of sine x, and x less than 1. So this is the only answer that we can get for lesson. Any question?